Okay guys, this is a continuation of our systems of equations. Sorry, I had to pause and go ahead and extend our screen so you could see everything that was going on. So what we've been talking about for this whole week and what we are going to continue to talk about is systems of equations. Our objective is 8.8. The student formulates systems of linear equations from problem situations, uses a variety of methods to solve them, and analyzes the solutions in terms of the situations. With this, as a student, what you want to accomplish and you want to be able to say at the end of all of this is that I can analyze situations and formulate systems of linear equations in two unknowns to solve problems. I can solve systems of linear equations using concrete models, graphs, tables, and algebraic methods. If you are comfortable with saying that, then you are more than ready to move on to the next statement. So what we are going to do today is we're going to solve systems of equations with substitution. As you've been told, we have numerous of ways that we can solve. The idea is to determine which method is the easiest for that particular problem, which one you feel most comfortable with. These notes, yet again, are how to solve the system algebraically using substitution. So if you're referring back to our notes that come in kind of a packet, you want to look at the day 5 and day 6 notes for filling in examples. The first step that we want to consider when we are looking at solving systems of equation by substitution is to solve an equation for one variable. For us, we want to pick which variable seems the easiest to get used to. We are the magic mathematician, so we can solve for whatever we want. X, Y, A, Z, anything, whatever we want to do. And then we are going to proceed by plugging in the equation we solved in step 1 into our second equation, or the equation in which we did not simplify for one particular variable. Step 3, we want to solve the equation and get the variable by itself. So we're solving for the opposite variable than what we got in step 1. Step 4 is to plug back in and find the other variable. We want to substitute the value into the equation. So these are our steps. As always, if you need to pause and write these down, please feel free to write them down. And if you're going to be in study skills, we'll have a foldable to extend on this a little bit, help us remember our steps. If you're not in study skills and you don't want to pause, you have these up at the top of your day 2 part 2 notes. Finally, you want to make sure to check your solution, and to do that we want to substitute both of our ordered pairs into the equation. Here is our first example. We have x plus y equals 5 and y plus 3, or y equals 3x plus 5. Sorry guys. When we're looking at this, considering our first step, we want to solve an equation for one variable. Luckily for us, the second equation is already solved for y. So we're just going to continue through the step process by looking at step 2. And we are going to substitute. So remember, you guys have used an IXL version and you guys have already kind of been mind prepped for the fact that when we are given information and we are told one variable equals something, we can plug it in anywhere we see that variable. So that's exactly what we're going to do. We're going to plug it into our first equation. So we will now have x plus, open parentheses, 3 plus x equals 5. We want to proceed to solve the equation. Your magic mathematician skills come into play now, and you can manipulate and move around as you choose. I will remind you, it is easier to move everything away from the x. We don't want to move more than we have to. We have 2x plus 3 equals 5. If we subtract 3 from both sides, and if you guys still need to draw the line and show this, feel free to. We will get 2x equals 2, and now we can think, because we are intelligent thinkers. We can think through the fact 2 times what equals 2. Hopefully you're able to derive that x is equal to 1. As of right here, we are not completely done. We need an ordered pair to be the solution. So what we want to do is plug that value back in to find the other variable. As discussed, it is not necessary that we plug it into one equation or the other. We can choose whichever one we want, but ultimately it is easier to plug it into the equation that we had already solved for. So here is, we're plugging it back into the first equation, and we have 1 plus y equals 5, and we need to solve for y. So to do that, we'll take away y from both sides. Take away 1, sorry. I'm getting excited. If you wanted to take away y, you could. You would be moving it around a little bit. And we'll get y equals 4. Just a refresher, guys, I'm not showing the steps on this PowerPoint like I have before because we have been through these steps a lot. And at this time, you do need to start getting a little bit quicker at working through them. Finally, we want to check our solution. So our solution is the ordered pair 1, 4. We want to plug that back into the first equation. 1 plus 4 does equal 5. 4 equals 3 plus 1, which is true. So lucky for us, we are on the right path, and we have properly solved systems of equation using substitution. We're going to stop this video now. This is the first example. There will be more examples. You can choose which you want to continue, or if you're comfortable, then just stop. And I'll see you in class. Hopefully you guys are working on your projects.